Hey guys, welcome back to my channel, and today we are going to be doing something really fun. We are going to be replacing this stepper motor on my artillery Sidewinder and replacing it with this one. Hey Kat, what are you doing? Alright, well let's get into it. Alright, don't mind my cat, he's just looking for a window. Alright, so a few weeks ago I was printing something on my printer and something caused a layer shift. What happened is that the head was coming all the way over and crashing. So if you don't know anything about stepper motors, after a while these things tend to lock up. So on a usual printer you should be able to just move this. A little bit of tug. Can't really do that here considering this thing is now locked up. So I've ordered this new stepper motor and it's supposed to be a replacement for this stepper motor, but there's one tiny issue. Is that this stepper motor is slightly bigger than the one that's on here. So we're going to see if this stepper motor is actually going to work. I don't know if it will, but I bought it. It looks like a suitable replacement. The shaft might be a little big, but we'll see how this turns out. So let's start taking this monkey off and let's see how it does. Alright, so the first thing you want to do is take an Allen wrench and take out these two screws right here. That's what's going to detach the motor somewhat from that spot. So the idea is you just want to get the motor. Really simple. So just take an Allen wrench, undo those screws. I know my hands are big, but yeah, these screws are really in there too. So make sure you do get to that part to where you can just get in there, undo the screws, take them out, and then that's pretty much it for the first part. Next up, you want to remove the connector that is on the motor. Now this connector was particularly stubborn. I don't know why. I thought there was glue on it, but it really wasn't. It was just snugged in there tight. So do your best to pull out the connector without tearing out any of the wires from the crimps. Otherwise, you got to get a whole new set of wires and new JST connectors along with new crimps. And if you don't have any crimpers, then that's a problem. So that finally came out. So now we have to go underneath the printer because there are some screws that are securing the motor to the railing. So it was really tough to kind of see, but I will show you right here where they're at. Alright, so there's a screw and there's another one on the other side. Now, don't be like me, be smarter. Before you actually do any of the screw movement, be smart and just raise the Z-axis. Yeah, in hindsight, when I was putting it all back together, I didn't realize that raising the Z-axis would have been a little bit smarter. It would have been making access to these screws a little bit easier. But just take your Allen wrench and undo the first screw that you're seeing here. And then on the other side, on the inside, there's another screw exactly the same. Go ahead and undo that and the motor should just come right off for you. Real simple. So now that we got the motor, the next part is to remove this blue attachment and transfer it over to the new motor. So get another Allen wrench, undo the next two screws here, and make sure these things are really tight. So I don't know why I keep on going with the short end, but use a little bit of torque and go ahead and undo it and just kind of pull out those screws. Yeah, and then when you're done, just come ahead and just transfer that blue part over until the new motor. Now keep in mind that where the connector is facing on the printer, you need to have the same connector on the other motor facing out in the same direction, because that's where obviously the connector is going to go. So make sure when you do transfer over this blue attachment that the connector is actually facing in the same direction. So when we go to put it back on, there's no issues. The connector should just slip right on in there. Very simple, but it's super important because I've seen people easily mess up and then have to take the whole thing apart and readjust this attachment and do it again. Not just with this printer, but with printers like I work with at work. I've done it before too. So just make sure the connectors are accessible for the new connector. Next, you want to take off this attachment that's on the shaft. That's what's really going to connect the belts here. So make sure you get another Allen wrench and you just go ahead, undo the torque and just pull that part right on off. Make sure you have the right size, because I didn't have the right size initially. So make sure when you're putting this attachment on the shaft that you are making sure that the grub nuts, at least one of the grub nuts, are on the flat side of the shaft. So when you tighten it down, when this thing is in motion and it's working, it's not going to create any type of slippage. So make sure that it doesn't matter which grub nut you gotta use, or grub screw, whatever you call it, just make sure that one of them is on the flat surface of the shaft. All stepper motors have a flat surface of the shaft, and that is for the grub screw to connect to that shaft as securely as possible, so there's no slipping when the printer is in motion, or any other application that is being used by the step motor. So make sure that, again, can't stress this enough, that the flat part is on a grub screw. All right, now with this, there's no right or wrong way to align the attachment onto the shaft. I would just make it to where you have access with an Allen wrench and make sure that it is tightened down. Okay, next we're going to take the last two screws that we have here and make sure that we have this whole blue attachment here attached. So now we're going to take the last remaining screws and we're going to put them back into their respective holes, just to further secure that the thing is on the right spot. So all stepper motors are somewhat the same. They're just bigger, smaller, have more torque value, etc. But most of the standard design for stepper motors are pretty much the same. So like I said, this stepper motor was marketed as a direct replacement for my X-axis, even though it's bigger, but all the screws seem to fit. So far so good. You want to make sure all these are tight, because again, this thing is going to be moving back and forth, creating all sorts of motion. Make sure these screws are tight so this blue attachment is not in any way making it to where you're getting any type of errors in your prints. All right, on to the next part. So now we're reattaching the motor, and as you can see, we have these two magnetic grub nuts that are here. I guess that's what they're called. Magnetic nuts, grub nuts. They're sitting in the railing. Again, make sure when you get to this part specifically, when you're removing or replacing the motor back on, make sure that you do lift the Z-axis. I went ahead later on and I lifted my Z-axis to make sure that this thing is going to be adequate to where it's going to work right and it's not going to be a pain in the ass to put back together. So just save yourself a headache. Put the Z-axis up. I mean, it doesn't have to be really high, just enough to where you can get in there. And I have big hands. My hands are really big, so I have to make sure that I have enough room to accommodate these big monster-like hands that I have here. So also remember, you also want to make sure that you attach the belts first, because the moment you go ahead and put that motor on there's not going to be enough clearance to put the belt back on. So put the belt back over the motor and adjust the tension as you would anything else. So tension is very important here. So make sure that you do that. Otherwise, you're going to have some issues trying to do it. Another issue that I ran into is that these grub screws here, they are actually movable. They move around. So I took a ruler and I measured center to center between two holes, and I measured it to be about 2 inches and about 1/8. So if you can go ahead and align those up, those screws that are on top, that'll be probably worth not enough of a headache for you guys. I wouldn't say not enough of a headache. No headache at all. Let's say that. All right. So about 2 1/8. So adjust those magnetic screw nuts. I really don't know what you call them. I wish I did. And that will be where you go from there. So like I said, make sure you do go ahead and adjust the belt around the motor first. And you can actually, when you're screwing these in, slide the first grub screw back and forth to give it more tension there in the belt, because it's actually very important that you maintain the tension that is in the belt. Otherwise, you're going to get slippage, you're going to get layer shift like I did originally. It's not going to be fun, and you might even have your motor crash or your head crash, and you'll have to be doing this process all over again. So make sure that there's quite a bit of tension in the belt. Here, make sure that you also move the motor over to the edge of that rail, because that is where you're going to get the maximum the maximum tension in the belt. All right, well, the new motor's on here. Seems like it's a perfect fit. A little bit larger in terms of depth, but I think it'll work. The connectors just get in there, but I think for the most part that'll be fine too. So let's turn it on, let's home it, and let's see what it does. Whoops. Alright, tools, home. Perfect. Alright, let's see if we can throw a test cube on here on something. Right, so we are in Simplified 3D, and I'm using this little small XYZ calibration cube. This thing, I use it for pretty much calibrating all of my printers whenever I do an upgrade or whenever I have to fix a part, just to make sure that everything looks good and is calibrated properly. All right, so you can get this thing on Thingiverse. I'll link it in the description. Very useful little tool, and it has an XYZ, so you can see which axes are kind of under extruding, or if there's any issues with it, you can pinpoint that particular axis and do something about it and fix it, whatever might be the problem. So very handy. So processes 1, we're using my artillery Sidewinder at a 0.4 nozzle. My retraction speeds, they stay the same because I haven't really messed with those. Layer 0.2, and I do my first layer speed here at 10% of the max speed. My max speed here is 70 millimeters a second, so this thing is going at 7 millimeters a second to lay down that first layer, and I don't have any regrets about that, because first layers lately I've been having trouble adhering those things, so slowing down my print speed actually does a lot. I know that 7 millimeters a second is pretty slow, but first layers are important, so you want to make sure you're doing what you can to maximize that first layer adhesion as possible. Additions, I'm using 2 skirts here. Infill, triangular, 10% with a 15% overlap. There's no supports. Temperature 60 degrees Celsius for the heat bed, 210 for the nozzle. Cooling, I have it 0, and then 100 when it gets to the second layer. G-code, I don't mess with that. Scripts, I don't mess with that. Speeds, as I said before, 70 millimeters a second. Everything else seems to be a-okay when it comes to that. So let's slice this thing. Let's see what it looks like. You're looking at about 31 minutes of print time printing this thing. So we're going to see how it does with this new motor, and hopefully everything turns out okay. So let's go throw it on the printer. All right, there she goes. Taking her sweet time because it's at 7 millimeters a second, but it's doing her thing. You can see that it is extruding. The motor seems to be working fine. Don't really have any complaints, so we'll see what it looks like in 30 minutes. You can get a better shot. There it is. Alright, 30 minutes. Alright, she just finished. Not half bad. Ugh. This thing is always stuck on here. Hang on, let me prop this thing up. And here is the final product of this cube. Really simple test that you can see if your printer is working right. Again, I was only concerned about the X axes here, so this X came out a little bit better, a lot better considering that I didn't have a motor before, but there are some cracks in it you can see, but that's when you consider printing at a 0.2 millimeter layer height, it kind of is going to do that. But yeah, you can find a link for this little guy in the description. You can blow it up, make it bigger, you can make it smaller to test the accuracy of your nozzle and your prints. It comes in handy. So I am satisfied with how this cube turned out. So that's telling me that the new motor that I just installed works a-okay. So thank you guys for tuning in. I really do appreciate it. Please like and subscribe. And my next video, I'm actually working on turning my Ender 5 Plus into a direct drive. So if you want to see a video on how to do that, I know most people they're okay with the boat and tube. I don't like the boat and tube. I like direct drives better. All my printers, except for the Ender 5 Plus, that's now a direct drive, are all direct drives. So if you want to see that video, let me know in the comments. Subscribe to the channel. I'm going to be bringing you more projects, and I hope you guys do stick around. It'll be fun. So I'll see you guys next time. Have a good one.